Modeling by way of variations. Consider how we write equations that model reality. In our first example, we look at the formula for the area of a circle. We know the area of the circle is equal to the number pi times r squared. And the way you would say this with variation sentence would be that the area of the circle varies directly as the square of the radius. And that implies that A, the area of the circle, is equal to the constant pi times r to the second power. That's direct variation. And we just multiply the r squared times a constant of proportionality, pi. Next example we're going to consider is the area of the triangle. Now we know the area of the triangle is 1/2 base times height. The way we would say this in a sentence for joint variation would be the area varies jointly as the length of the base b and the height h. Now varying jointly means we're going to have the product of these two variables, base times height, but then we have to have our constant of proportionality. In this case it's 1/2, so A equals 1/2 times base times height. And finally, consider the electrostatic force between 2 point charges Q sub 1 and Q sub 2. That force, that electrostatic force, is said to be jointly proportional to the magnitude of the 2 point charges Q1 and Q2, and it's inversely proportional to the square of the distance r that separates the 2 point charges. And the way that we would write this expression, this joint variation, is F equals K times Q sub 1 times Q sub 2, that's the joint proportionality of the point charges, over r squared. That's the inverse proportionality of r squared. What I want you to notice is the constant of proportionality. In that case, it was K. But in each of the problems, they each have a different constant of proportionality. I'll circle them here. They are values that do not change. You don't substitute different numbers for those. Those stay constant. For the first example, the constant of proportionality was pi. In the second one, it was 1/2. And in the third one, it's a generalization. It's K, because for different situations, different types of electrostatic force situations, you would have a K. But once you've established what that proportionality constant K is, it would remain the same for that particular problem. So those are demonstrations. That's our demonstration of how the reality of these three examples are modeled by direct proportionalities, and the second one was a joint proportionality, and the third one it was a joint and an inverse proportionality. And each of those involves a constant of proportionality.